So I want to talk about, I guess I should recite my resume. I built Ingres 1 million years ago. I built Postgres 500,000 years ago. And since then, I built Vertica, I built SciDB, I built VoltDB, and now I'm going to talk about Data Tamer, which is a data curation system. It's not a database product. So I've been interested in data integration for a long time. And the current state of affairs is that data silos are everywhere. FedEx has 5,000 operational data systems. A big enterprise like Verizon has 10,000. And there's huge value in integrating these disparate, independently constructed operational databases. Now, how do we get to this annoying state of affairs of having so many silos? Basically, large enterprises are divided into business units, and to get anything done, you make them independent. So these are independent business units with independent data stores. And even if you could integrate your own data stores, the minute your CEO buys somebody, then you've got a data integration problem of all their stuff. So if you're in the refrigerator business, the plumbing supplies business, et cetera, those are almost guaranteed to be independent data stores. Not to mention that marketing and sales and engineering all have their different data stores. So there's just a proliferation of silos. I know of no large enterprise that has a global data model. So these 5,000 data stores have no overreaching data model to put them together. Why is that? Because they're independently constructed. They have different customer IDs, different product IDs. A very popular pastime back in the 90s was to put 7 guys on a project to build a global data model for an enterprise. Those all failed, every single one of them. The reason is that this was a multi-year project. You got to go out and find them all, figure out what they're doing. And even if you could put them together, you'd be out of date on day one because enterprises are dynamic and things change. So I know of no such global data models. So without a global data model, you're faced with a data curation problem, or you can attempt to autocratically create standards. Enterprises have been trying to do that ever since I didn't have gray hair. It's really difficult. It's really difficult to stamp out multiple independent systems, let alone things like Macs, which of course I'm using. So we're faced with lots of silos. Why do people want to integrate such silos? The number one reason I hear from practically everybody is cross-selling, which is if you happen to have a loan with a large enterprise bank and you call them up and talk about servicing your loan, they want to try and sell you something else like checking accounts or whatever. So cross-selling, to cross-sell, you've got to integrate these silos. Social networking, which is, I'll talk a bit about a large pharma company that has 10,000 biologists and chemists. They want to figure out who's working on the same stuff, et cetera, et cetera, et cetera. So integrating silos is a very big deal and is the biggest problem facing a lot of enterprises. So for a while back, 10 years ago, I was on the technical advisory committee for Citibank. This was their number one problem. So the number one thing that keeps their CIO up at night. So if you want to do data curation, life is actually very simple. You want to find the data sources of interest. You've then got to figure out how to parse them and ingest them into some central place. Most people are willing to admit that around 20% of the records in any data source are garbage. So you've got to fix get rid of or correct garbage. If you want to put data sets together, if you're the human resources guy in New York and I'm the human resources guy in Paris, you have employees with salaries, I have employees with salaries. Your salaries are in dollars, my salaries are in euros. You've got to do transformations. Put these schemas together, you've got to match up attributes. Your salary is my wages. And then one of the most difficult things you need to do is what's called entity resolution, which is if you see the same entity in multiple data sources, you want to put those records together. So that's all you have to do is LIVTMC. Why is this hard? Well, here's three sort of random fictitious records. I bought $100,000 worth of widgets from IBM Incorporated. That's one record from some data source. From another data source, I bought 800K euros of M widgets from IBM SA. And then from a third data source, I bought minus 999 of star with star from 500 Madison Avenue, New York, et cetera, which happens to be the official address of IBM. So what are your problems? Well, first of all, you've got missing data. Minus 9999 or minus 99 is a very popular code for data unknown. Basically, it's a code for null, often. You've got dirty data. Star with star, what does that mean? Is that the same thing as a widget or something different? You've got multiple currencies. You've got to translate that to common form. And then there's entity resolution. Is IBM SA, which is a Spanish company, the same thing as IBM Incorporated or something different? And then are M widgets the same thing as widgets or something different? So you got to do all of this. So I'm going to tell you sort of how people have done this in the past and what needs to be done today. So the first generation of data curation products was traditional extract, transform, and load. Second generation was to put ETL on steroids. And the third generation is to do this scalably with a very different architecture. So all major enterprises got into the data warehouse business in the mid to late 1990s. It was sort of started off by people in the retail sector who wanted to integrate sales data. And the whole idea was to do better stock rotation decisions. So you want to figure out that pet rocks are out and Barbie dolls are in. So you have your buyers sort of tie up Mattel with a huge order for Barbie dolls. And you send the pet rocks back to wherever they came from. So rotating stock, the average warehouse paid for itself within 6 months with smarter buying decisions. Everybody did this with retail sales data. So customer-facing data went into warehouses very early. So here was the methodology that you used to build a data warehouse. So you sent a human out to define a global schema in advance. You created a global schema up front in advance. Now, I already said that was impossible for the whole enterprise. But if you do it on a small enough amount of data, you have a chance of getting this done in a finite amount of time. So you start with a global schema. You then, for each data source, you assign a smart programmer to go out and interview whoever owns that data source, understand it, figure out what's in it, figure out how to parse it, and write a local to global mapping in some scripting language. All the ETL vendors have proprietary scripting languages. You then get to write cleaning routines, and all of that's constructed into a workflow of runtime ETL, which you then run periodically. Now, I know a lot of people who own data warehouses. I don't know anybody who integrates more than 25 data sources using this technology. Now, if you really hammer me hard, I'll give you 50. But most people, it's 10. So this scales to a few data sources, and that's it, because it's too human intensive and it requires an upfront global schema. So bigger global schemas upfront are really hard, and there's too much manual heavy lifting by a trained programmer, and you don't have hardly any automation. So that was generation 1, and it scaled to a few data sources very, very successfully. Well, generation 2 was to add curation tools to your ETL products. So deduplication systems for addresses, people names, outlier detection to do data cleaning, standard domains for data cleaning, and so forth. This gives you more features in a generation 1 architecture, but it doesn't solve the scalability problem. You still only scale to about 25 data sources, and then you're done. So the current situation is that enterprises want to integrate more and more data sources. I'll just give you a couple of simple examples. I got to make a sales call on Miller Beer a while ago in Milwaukee, and they had a very traditional customer-facing data warehouse of beer sales by zip code, by distributor, by type of beer, and so forth. So this turned out to be in December of a year in which El Nino was widely forecast to be the winter weather pattern on the West Coast. So that's a mid-equatorial upwelling of warm water off of Peru. Turns out to screw up the US weather something fierce. It makes it wetter than normal on the West Coast, which is, of course, obviously not happening right now. And it makes it warmer than normal in the Northeast. So I asked the Miller Beer guys, are beer sales correlated with either precipitation or temperature? And the Miller Beer guys said, boy, I'd really like to know the answer to that question. But of course, the data wasn't in the data warehouse, and so business analysts have an insatiable demand for more. So that just generates demands for integrating more and more and more data sources. What's more, public data on the web makes lots of additional data sources available. So there's this upwelling of demand for integrating more and more data sources. And so how are you going to cope with having to scale? So ETL has no chance of scaling. It's just too much manual heavy lifting, and the traditional ETL mechanism is just way too heavyweight. What's more, there's a personnel mismatch, because one of the things in our example from a few slides ago was you have to figure out, are widgets and M widgets the same thing? Well, the ETL programmer has no clue what the answer to that question is. It takes a business expert to figure that out. So only a business expert knows the answer, and he's not the guy writing the cleaning routines, it's the ETL guy. So you've got a personnel mismatch of what you need to know is not something that the ETL programmer has any chance of figuring out. So it won't scale, and you've got the wrong personnel mix. So about now, you guys have all wandered out onto the exhibit floor, and there are probably 100 vendors who are saying, the answer to your problem is just put all these silos into a data lake. So that will allow you to have located the data sources of interest and ingested them. And that gets the data into a data lake. Cleaning it, doing schema integration, and doing entity consolidation, your data lake does nothing for the rest of your data curation problem. So what that will generate is a whole bunch of crap in your data lake, and the result will be a data swamp, which is sort of pictorially shown on this slide. So have at it, create a swamp. You haven't solved your curation problem. You haven't done hardly anything about it. You've located and ingested data, and that's the easiest of the issues to deal with. Okay, a better idea is to run a new generation of data curation tools that are focused on scalability. Now, if you want to scale past 10 or 20 data sources, you've got to use automation. So you want to scale to 1,000 or even 10,000 data sources. So it turns out one of the production customers of Tamer is Novartis. Novartis wants to integrate 10,000 electronic lab notebooks from their 10,000 biologists and chemists who are doing wet biology and chemistry. 10,000 data sources. There are 1.3 million attribute names in those 10,000 data sources. That's what Novartis wants to do. ETL has no chance in getting anywhere near this. So think scalability. The only possible way you're going to be able to put together 1.3 million attributes is by picking all the low-hanging fruit using machine learning and statistics. And it turns out it works like a charm. And the reason is that humans aren't that clever at inventing names for things. So after you've asked a human a few times, other names that people come up with tend to match what you've already seen. So you got to pick the low-hanging fruit automatically and ask a human when you can't figure it out. And you've got to run all your algorithms in parallel. And anything that is n squared, where n is the number of things you're messing with, is going to be an n cubed or n squared calculation. N squared on big numbers of things is a no-no. So scalability means be able to do it on lots of records, lots of attributes, and lots of data sources. So I say we've been used very successfully at Novartis. You can get 95% of their problem solved without having to ask a human. So if you want to write a scalable data curation system, there are 5 things, in my opinion, that you absolutely have to do. And so I'm going to tell you what you should look for if you're looking for a data curation system. So we'll just limp through these one by one by one. I don't know why you guys are bothering to take pictures of the slides. You're going to get them all, anyway. But anyway, have at it if you want. Okay, so tenet number 1. Data curation is never done. What does that mean? Which is you're going to add new data sources on a regular basis. Why is that? Because business analysts have an insatiable demand for more. What's more, even if they didn't have an insatiable demand, your CEO will buy somebody, and that'll give you, more stuff to mess with. New data from data sources is constantly arriving. In other words, you can't view this as a static problem of ingest a data set into your data lake, because the data source you're ingesting is going to change out from underneath you. So you got to be able to accept new data, whenever it appears. So a major car manufacturer is using Tamer to integrate customer data in 30 European countries. And as cars are sold, you get new records. And so the whole idea is to enhance customer experience as they move around the Eurozone. So you got to be able to deal with dynamic data sources as well as new data sources. And then the other thing that you have to deal with that's a little bit insidious is that what your data looks like may change. which is you're integrating salaries, and you're expecting salaries that are between 0 and say 10,000. You buy your CEO buys an Indonesian company, and all of a sudden salaries are completely different than what you've been expecting. So business conditions or products evolve, rendering sort of your old model of what things look like obsolete. So data curation is never done. Your integration problem is going to keep changing. So why is that going to be a big deal for you? Well, there's some obvious conclusions that you need to draw. The first one is you cannot assume a global schema up front, because even if you could construct it up front, it will be obsolete essentially immediately. So you got to build the schema bottom up, and you can't, you have a silly way to do this is to assume some smart human is going to give you a global schema in advance. All curation algorithms have to be incremental. You do it at time 0, and then you do it at time 1, and then you do it at time 2, and so forth. And they have to be incremental because it's silly to redo the whole batch of everything every time you add a couple new records. Now the key message is the one here at the bottom of the slide. Fantastic. This is Andy Palmer, who's the CEO of Data Tamer. He says his main job is carrying my bag. Okay, so a popular tactic for you guys to all use that I hear all the time. I'm not smart enough to do this, so I'm going to outsource this to Palantir or pick your favorite consulting organization. Don't even think about doing that. Why? Because your expensive consultants will appear at time 0, and they will do your integration problem at time 0. At time 1, that's obsolete. So then you have to invite them back to fix their model. And then you have to do it at time 2, and so forth and so on. So you're going to give your consultant a long-term guided tour through your wallet whenever anything changes. So in my opinion, you've got to develop in-house competence, or it's going to cost you more money than you want to think about to try and do this. So don't assume there's a global schema. All curation algorithms have to be incremental, and this has got to be an in-house project, not something you trust to external consultants. Second thing is you can't require a PhD in AI to be able to run data curation. And that should be fairly obvious. In fact, Tamer uses buzzword 1, buzzword 2, buzzword 3, ... But you don't have to understand any of this stuff. It's all completely under the covers. And so you don't need to understand what statistics-based blocking means. We're happy to explain it to you, but you don't have to know it. So you don't need a PhD in AI to use a system like Tamer. Don't run anything that requires you to be smart. After all, there's an intergalactic shortage of trained data scientists, and that shortage is going to continue for quite a while until schools generate a much bigger supply of trained folks. And so you can't require excessive amounts of smarts to use an integration system. You have to use one that can be understood by mere mortals. And in any case, Palantir is hiring all the data scientists it can. It can outbid you for talent. And if you're going to hire an external organization, it has this wallet guided tour problem for the indefinite future. So don't use an integration system that requires you to be an expert. Use one that can be run by mere mortals. So that's tenet number 2. So tenet 1 is it's got to be incremental. Tenet 2 is you have to be excessively smart to run this stuff. Now, Tenet 3 is true of almost no integration systems I'm aware of, which is you've got to include expert sourcing. So what does that all mean? Well, first of all, when I say expert sourcing, do not think Mechanical Turk. So Mechanical Turk farms out questions to random untrained people. Think of them as Aunt Maud from Cedar Rapids, Iowa. That isn't the problem that any enterprise has. So just for example, I mentioned Novartis. Well, they have a genomics thing that's called an ICU 50. And if you don't know genomics, you have no clue what I'm talking about. But is it the same thing as an ICE 50? Only somebody who has a great deal of smarts in genomics, not in AI, in genomics, and Novartis has a ton of those people. So it requires expertise. You cannot farm these decisions to Aunt Maud, because most of them are going to require your business enterprise expertise. Now, why do you need to invoke experts in the first place? Well, some decisions simply cannot be made automatically. A system out of the box has no clue whether an ICU 50 is the same as an ICE 50. You have to ask a human the first time. After that, you know the answer, and you don't have to ask again. But you're going to need expert help. And there's lots of cases where this appears. Using a accessible example that everybody can understand, if I see multiple restaurants at the same address, is that a food court? Is it a data error? Is it one went out of business and got replaced by the other one? An automatic system has no clue which of those three is true or whether it's even something else. So you've got to invoke experts, and they have to be domain experts, not Aunt Maud. And expertise is invariably hierarchical. So it turns out the intergalactic genomics expert at Novartis is a guy named Wolfgang. He's in Basel, Switzerland. And so at the end of the day, if you really want to know the answer, he's the person to ask. And then there's sort of lesser tiers of expertise within the company. But expertise, you've got to take advantage of the fact that expertise is very hierarchical. And the answer to expert sourcing cannot be ask every question to Wolfgang, because he will clearly tell you to go fly a kite fairly quickly. So you can't send all questions to Wolfgang. So you have to have a sophisticated system that understands hierarchies of experts, that understands that some experts are more expert than others. And when you ask any expert, you also have to ask somebody who's smarter than they are, so that you can score the expertise of any given individual. And people who are usually right, you promote. People who are often wrong, you demote. So you've got to have an expert sourcing system, and it cannot just be Mechanical Turk. So we spent a lot of time building exactly such an expert sourcing system. And it's got to be focused on enterprise and not on, Aunt Maud. Okay, so that's number 3. Number 4, you've got to fit into the enterprise ecosystem that's already there. So you've got to ingest from all kinds of data sources. Now, that includes things that people don't usually like to talk about. Text. It also includes things like semi-structured data. So you've got to be able to ingest from gnarly data sources, and we're happy to do that, but this is part of fitting into the enterprise, is that you have to get the data from wherever it is in whatever format it is. You got to export to wherever people want stuff to go, which is often a data warehouse, but it may be something else. One of the things that we didn't realize until recently was that our original model was you just suck data from wherever it is, and then you spit it out to wherever it needs to go. So there are upstream data sources, and you spit out the downstream. Well, in a bunch of enterprises, you cannot read the data source. You've got to leave it where it is. You cannot ingest it. That may be because of regulatory reasons, privacy reasons, size reasons, administrative controls, whatever. So you've got to be able to leave data in situ and operate on it with your standard system, even when you can't read all the data. We get asked all the time for access control, which is, this is a bunch of data, you got a bunch of people accessing it, and you want to be able to say who's allowed to do what. And then most enterprises have a bunch of partners that they deal with. So you've got to be able to interact with whoever the enterprise partners that any given customer wants you to deal with. So you got to play nice with whatever's there. Okay, tenet 5 is you've got to have a scheme for finding data sources, which is the first thing that I said you had to do is locate the data. The average CIO, a favorite question for all of you to ask your CIO is, how many data sources do you have? How many data sets are in your enterprise? And the average CIO will say, I have no idea. And he will also say, I have no idea how many duplicates I have in various divisions with exactly the same information, often purchased from third parties multiple times. So you've got to have a metadata catalog to assemble all kinds of data sources so that people can decide what they want to ingest. So go check out our metadata catalog. We're at booth 531. You've got to have a mechanism for finding stuff and cataloging it. Now, the other thing I think that's really fun is that I see a lot of integration problems, and there's a lot of commonality across the various enterprises who are doing roughly the same thing. So, for instance, in procurement optimization that I'll talk about in a minute, which is you're trying to integrate ERP systems, most everybody has roughly the same problem. So you should bake in the 60 or 70 or 80% that's common and just give it to people so they only have to add their 30%, leaving a smaller problem for individual enterprises. So we have such templates in 3 different areas right now. CDISC, for those of you who've never heard that acronym, is basically running FDA drug trials. And we have more in the wings, and as we see commonality, we will simply bake it in, hand it out, so that you get less of a problem to deal with. So, I want to end with a case study with a very, very large company, which is in the Fortune 50. And what this company wants to do is they want a master data set of suppliers. Now, they have more than 300 ERP systems. They're highly divisionalized. Every division has its own ERP system. And in each ERP system is all the suppliers that division happens to work with, and what the terms and conditions are by which they buy stuff. So these are independently constructed and maintained. There are no standards. As I say, these are what business units do. They do their own thing. And new ones come out of the woodwork with surprising regularity. which is, the company doesn't even really know how many ERP systems they actually have. So the gleam in the eye of the CFO is the following. Most of these 300 ERP systems have Staples as a supplier. So they're getting paper goods and stuff like that from somebody like Staples. Well, so Staples has 300 contracts with this particular company, one per ERP system. The terms and conditions vary widely. And so the CFO wants to give each procurement officer a view of what all the other procurement guys have managed to negotiate. So that if I'm a procurement guy and I see that some other division has managed to get a better deal than I got, I'll simply demand that Staples give me the better deal that they give to the other division. So I want to get what I would call most favored nation status, which is I want the best deal that anybody in this Fortune 50 company managed to get. And there's unbelievable potential ROI here because the payment terms and conditions vary widely, in some cases by an order of magnitude. So we're working great at scale, doing these, integrating these 300 ERP systems. Just to give you one small statistic, if you add up the total number of records that are in these 300 ERP systems, you would, of course, expect a lot of duplicates. Most everybody deals with Staples. So in our integration database, there's 20% of the total number of records. So by 80% are duplicates. And so that just says the ROI is dramatic. So procurement integration is basically this problem, and everybody on the planet has this problem. And so we're pretty good at it. We have a template for this for supplier mastering. Go check it out at our booth. So in summary, Tamer is a third-generation data curation system. It's incremental. It does schemas bottom up. Does not require a PhD in AI. It fits into your enterprise ecosystem. It comes with a data cataloging system. And it comes with a bunch of templates if you happen to have a problem that we've identified a bunch of commonality. We have a bunch of production customers. General Electric is one, Toyota is another one, Roche is the third one. Check us out. We're here at booth 531. I have 3 minutes to spare, and I'm done. Thank you very much.